Okay, let's keep going. I prepared an article, I think it was like a few months ago, maybe 3-4 months. I prepared an article because the people in LACNIC is the equivalent to RIPE in Latin American Caribbean. So I was in a conference we have the LACNIC meeting in Brazil, and then the following week I was in a conference sitting in front of 6,000 ASPs from Brazil. And they told me, look, we need a guide. We don't know how to do it. Can you give us 10 steps to deploy IPv6? And I was thinking, wow, how to give them just 10 steps? Well, I started writing it, and after a couple of hours, I got 12 steps. So it was close. So this is basically very rough idea about how I will do an IPv6 deployment in general steps. And this is meant basically for ISPs, but it's very, very close if you are an enterprise network or a government network or something like that, okay? So the first thing is requesting the prefix. One of the bigger mistakes that the people is doing is they go to RIPE and they said, give me an IPv6 prefix, which is wrong. Because you first need to understand the differences between IPv4 and IPv6 and count how many customers you have, different kind of customers, home, corporate, mobile customers, and so on, and then decide how much space are you going to allocate to each customer. The discussion that we have already before about if we give them /56 or 48, or for example, by default, cellular phones get /64, so you need to do all these numbers. And overall, I have done this picture for all of my customers, and it actually works very well. If you have 50 or up to 50,000 customers, you need /32. But if you have 100,000 customers, you need /31, and so on. So it's very simple. With this guide, you don't actually need to do the dressing plan from the beginning, but you can have a very, very route idea with this figure, okay? And this is assuming that you give /64 to cellulars and /48 to all the others, okay? That's the basic point. Then next step is you actually need to look into your network, see if you have equipment that may be older than maybe 6-7 years ago. Typically, your equipment, if your equipment is less than 5 years, for sure it has in general good IPv6 support. But that's something that will tell you if you need to upgrade something, licenses for new software or firmware, or if you really need to upgrade some boxes, I mean replacing hardware or updating it, and so on. One of the bigger issues, and somebody mentioned already before, is the CPEs. The big problem with the CPEs, and I am working with CPE vendors on this and also a document in ITF to update the CPEs, is they will not support IPv6, or if they support IPv6, they will support only dual stack and nothing else, no transition mechanism, or maybe they support the slide, but no other transition mechanism, okay? So one of the ways to cope with that is what I have done in these boxes. This is $10 boxes from China. They have dual radios, 2.4 and 5. I have connected up to 50 people in one of these boxes like the one that you have here. No problem. It has no external antenna, so it's very cheap, it's fast. It has 5 gigabit ports. And instead of any specific software, I am using a Linux. The Linux is OpenWRT. You probably heard about that. Now it's called LIDE. It's just another name. But with that, you can do whatever you want. So I can have here an AT64. I can have here BGP, whatever you need. Of course, you have the same. Exactly. Yeah. It's the same. And it's really, this is a $10 box with 5 gigabit ports. And I have stressed the box to handle with NAT, which is one of the most heavy operations for a box, being able to simultaneously transmit and receive 1 gigabit traffic. So it works. Okay? So people say, hey, replacing the CPEs is very expensive. Actually, you don't need even to replace them. If you have TR069, most of the CPEs in the market, I am not going to say 100%, but probably 80% of the CPEs in the market, you have a version of OpenWRT for them. So you can reflash them. Of course, one of the problems of reflashing, I am not sure how is the stability of the electricity in this country. If the electricity in this country is going up and down every 5 minutes, then you have a problem because you can get a brick instead of a router. Okay? But if that's not a problem, it's a possibility. Okay? Because when you are reflashing the box, if power goes down, you can throw away the box or open it. In this box, actually, the firmware they come originally, it don't support upgrading them. So I take the 4 screws, solder a serial port, and done. Okay? You do that the first time. It's not usual. Usually you can reflash them. But in this case, the original vendor put some protection so his firmware is not changed. Okay? But normally that's not the case. In US, it's happening sometimes because the FCC want to control what the open software is doing with the wireless interfaces, but that's a different problem. We don't have that problem in Europe. Training. I always say IPv6 is not really much difficult than IPv4. The main difficulty is change your mind. People in IPv4 think in a single IPv4 address, private addressing space, and all this kind of stuff. That's what you need. You really need to change to have your team in your operations and management staff to get used to IPv6. If you keep doing the things in IPv6 the same way as you do with IPv4, you are lost, definitively. Again, it's not more difficult, it's just different. You need a mentality change. Okay, that's a key thing. Upstreams, of course, you depend on the connectivity from others. So if you cannot get IPv6 from your upstream providers, which is not a problem today here, right? It's a problem?
Not really.
Not really, exactly. Okay. In Europe, in general, I don't see the problem. In general, I see the problem in some countries in Asia Pacific or even in Africa. But Europe, North America, South America, and most of Asia Pacific, you can get several competitive offers for IPv6 transit, so it should not be a problem. Same if you have in your network or if your IX is hosting copies of root servers. Not sure if you have a copy of a root server or something like that. You are hosting a copy of a root server? No?
Yes.
Yeah? Okay. And they are dual stack, right?
Yes.
Of course. You have caches from, I don't know, Akamai, Facebook, Google, and so on.
Yeah, of course.
All them require today that your network is IPv6. In fact, they don't configure the box anymore with IPv4. I don't know if you have seen that, but in several countries recently, they were offering to host caches with IPv4, and they said, no, we only host now with IPv6, nothing else, okay? Security policies. Basically, one of the difficulties of getting a new protocol or a new thing or new functionality in any network is security. In principle, whatever security policies you have with IPv4 are the same you should have in IPv6. There are a couple of exceptions. One I mentioned already before, you should not filter ICMPv6. Okay, that's a big mistake. And the other thing is you really need to check that path MTU discovery is working in your network. Okay, because most of the troubleshooting will come from these two aspects. So that's key, and many people is not paying attention to this because the same reason I explained it 2 slides ago, which is thinking IPv6 as the same as IPv4. It's not. Same for BGP. If your network is already supporting IPv6, one very important security policy that the people forget is to avoid transition mechanisms. Because if you have dual stack, you should not allow transition traffic to go in your network, because that could be used to make a hole, as I mentioned before with Teredo, to your security boxes. Okay? So that's a big change because it's something new. It's not nothing else than that. Monitoring. I have seen a lot of people that has very good monitoring for their IPv4 network, so they immediately realize if there is a degradation on the quality, or if the stability of the network or the prefix visibility is going low or whatever, but they don't do the same with IPv6. Why? Obviously, if you offer IPv6, you want to make sure that you are monitoring exactly the same as for IPv4. Okay, so that's a key thing. Detailed addressing plan. We already mentioned that you first need to know how much space you need. Once you get that and you have already done the audit of your network and trained your staff and so on, then is the right time to do the addressing plan. I will say the addressing plan, there are a lot of books on recipes on addressing plans in IPv6. My suggestion is don't look at them. They are good as general rules, but you really need to have a very deep knowledge of your network to design a good addressing plan. I really think it makes a lot of sense to invest as many weeks as needed to really make a good addressing plan looking at the very long term, because what you never want to do in a network is to renumber. Okay? So this is a key aspect that many people is forgetting. Another interesting thing is how many of you still manage your IPv4 addressing space using a spreadsheet, Excel, Word? Okay. Someone else? Only for IPv4. Okay. That's no way in IPv6. You need what we call an IPAM, IP Address Management System. There are appliances, there are open source applications, you choose. But you really need to have an IPAM. If you really want to have a good suggestion, there are IPAMs that do at the same time DNS and DHCP. So they integrate the three functionalities. That's probably the best advice, okay? Because you really want to have all integrated, not having different applications that you need to do interfaces among them and so on. So probably this is the best thing you should do. Then, once you have all this, up to now is basically planning, right? Now you go and deploy IPv6 at your core. If you have MPLS, that's really easy, so that should not be a problem. Possibly, you want to keep dual stack at the moment, but think that in the near future, maybe at least parts on your network will be IPv6 only. That's something that we are going to see in the next presentation. Trials. Engage corporate customers that want to make a trial. Engage your own corporate network. Engage residential customers, for example, your own employees. So it's important to really test things. Nobody is going to tell you you need to deploy IPv6 overnight. That's not, you don't have a chance to do that. It takes probably at least 6 months. I have done that faster. In 3 months, I have deployed networks with 1 million customers, but which are really, really huge effort in terms of human resources. Okay, it's very intensive. You actually said that that's part of the problem. Okay. Access network. Again, my recommendation here is think in the future. The future is you will not have IPv4. So it don't make sense to look into transition mechanisms or dual stack or anything like that that is forcing you to support IPv4 across your network. Even if you have that now, you need to look in further step. Okay? So basically you can just go with a single transition mechanism, and in my opinion that's 464xlat. You need to look into the future considering that everything will be IPv6, and the support that you need to provide now to your customers in terms of IPv4 needs to be considered like IPv4 as a service. So it's something on top of your IPv6 network. Okay? So when you have less and less and less IPv4 traffic, you don't need to reconfigure your network. It's just a service that is going less and less and less use, okay, in an automatic way. Transition configuration. Once you have your core and your access configured, and you have done some testing, you also need to configure the transition mechanism that you are going to go to use. So typically, if you go for something like 464xlat, you will need to configure your systems for supporting NAT and DNS64. Okay? This is something that it's obvious, but it's important to say that, because typically you are not going to have a single box. You will have some kind of high availability or redundancy, and you need to consider all details to know how those boxes will be able to be used from different parts of the network. If one fails, how the other one comes in action, and so on. Okay? And then the last step, of course, is update the CPEs, which is probably one of the bigger tasks, and start deploying massively the service. And well, I will say you are not yet done unless you start taking advantage of that. I mean, deploying IPv6 for the customer is nothing different. Customers should not notice that you have deployed IPv6. But from your perspective, in terms of business, the idea is, now that I have IPv6, or while I am already considering deploying IPv6, let's make a business plan for taking advantage of that. And obviously that means today Internet of Things. Okay? So deploying IPv6 brings you a big pool of new resources to do new things, to sell business to authorities, to cities, smart cities, government. There are a lot of things in addition to end customers that you can offer with IPv6, which IPv4, it will be possible, but it will be so costly that don't make sense. Okay, so keep that in mind. And I think that's it. I have this table already in the other. So that's it for this presentation. Questions on this? You may disagree with the plan, but it's very, very overall view of what are the steps. Okay, some of them can be changed or done in parallel. It's not necessarily sequential. Okay.